Hello, my friends of Qatari Labs. Welcome to the session number 3 of the module number 6, I guess. Let me check. Okay, as in any other class, let's open Anaconda Prom, CD Diploma, CD Documents, CD Diploma, CD Course 6, Dear, and then we are in session 3, MKDR session 3, CD session 3. Okay, and here we launch Jupyter Lab. Great. From the course material, we are going to copy the exe, and the model, Control C, and then we are going to paste it here in Diploma, in course 6, in session 3, and then we pasted the exe and the model. Okay, and we are going to follow the manual. Okay, in this case, we are going to couple a model that is built in Model Muse. Okay, and this model that is built in Model Muse is on Quad 3. Okay, so it's in a version of Model Muse that has the Quad 3 refinement, and then we are going to launch it here in FlowPy. Okay, so we can go to the Diploma, Course 6, Session 3, and on the model you are going to see, oops, interesting. There is no Model Muse file here. Let me check if in the course material there we see the Model Muse file. No. Okay, so you only have the manual, you don't have the whole model. Okay, the Model Muse project. Okay, well, don't worry. Okay, so here in our, okay, so we have launched Jupyter Lab. So here we should see exe and model, and we start a new Python 3. Okay, great. So, well, the model is something like this. Okay, so you have the sea, you have a river, you have some wells, and then you have and then you are going to see the discretized by vertex discretization. Ah, no, no. This is not done in Model Muse. This is a Voronoi mesh. Okay, you are going to see the Voronoi mesh. Um, let me. Mhm. Import FlowPy. I will make a util that import numpy smp import matplotlib.pyplot as plt import os. Okay, I will make a utility where you can make online Voronoi meshes. Okay, but this will be later on. Okay, so we say sim name. If you are here with me, please type 1. kimonas, where the model will be located. The model is located in OSPath apps path model, so in the folder model, but with the absolute path. So what does it mean absolute path? If you were curious, is the whole model, not from the your current position, but from the drive. Okay. So exe name is equal to ospath.appspath exe mf6.exe sim is equal to flowby.mf6.mf simulation load Modflow exe name is equal to exe name ws is equal to simw. And then we change, okay, why we change? Because we are going to import the model, but we are going to store somewhere else. Otherwise we will modify the original file. Okay, there is something missing here. And this is the folder where the model with the buoyancy, with the variable density model will be stored. Okay, great. Great. Okay, so we got the model. And this relative pi, the other time it wasn't working well, so that is why we are just, okay, I'm going to comment it because I'm not going to run this cell. Okay, and then we got the GWF. We are going to explore the model. We can get the package list. So we have general head, river, well, initial conditions. So we got the this v is equal to GWF get package of this v, and then we can print the top and the bottom. Okay, and those are arrays, okay, for every okay, okay, listen to me. When you are working in a normal grid, okay, when you are working in a normal grid, you will have uh, rows and columns, okay, and then you will have values every rows and column, usually in an array. When you work in an structured grid or this discretized by vertex grid, okay, you don't, there is no rows and there is no column. So that is why all cells are identified by an ID. So you forget about the concept of row and columns, and then just work with the ID concept. Okay, so every cell will have an ID. Well, it's hard to see which is the ID of the cell, while it's faster to see which is the row and column of the cell, but okay, we have to work in this way. Okay, so we can do a big AX. Okay, so this is the representation of the Voronoi grid. Okay, I have done some tutorials in Voronoi. What is the advantage of Voronoi? That you can get huge areas with a decent discretization over certain features, okay, with a minimal amount of cells, okay. Yeah, because in order to get discretization of 50, where the, oops, uh, when you got a discretization of 50 meters over maybe 10 kilometers, in a normal discretization will take you thousands of elements, okay, while here maybe we're working with just 10,000 10,000 okay, with just 10,000 cells. Okay, we can do also okay, a cross section. uh, Kimona asks if we can create a Voronoi mesh or Model Muse. No, not yet. Okay, I have developed my own tutorials and my own class to create Model Muse Voronoi grids. However, uh, Model Muse FlowPy has its own tools for Voronoi that are really limited. Okay, because they use the triangle. They use the triangle shape, the triangle uh, executable, and uh, there is also an issue in Model Muse that you cannot import model of Modflow 6, and this is also an issue. Why is that an issue? Because you cannot import geometries in Model Muse. There is a trick, okay? So you can create the geometries in Modflow 6 and then pass to in Modflow 2005 and then pass to Modflow 6, but this will be only the ones that are related to row and columns. Okay, but for Voronoi, there is no generation and no visualization. We can plot the grid. And then we can plot the, I'm going to copy this, the map view. Okay, and with that we are just plotting the boundary condition, okay, on aerial view and as well on cross view, on cross section. Okay, I will plot, no. We can also plot the boundary condition. We can also plot the river here. So we are going to plot two, okay, the river and the boundary condition. Okay, and then we can plot the river on cross section. No, cross view. Okay, great. Mhm. The well, yeah, sure. You just have to pick the name, well zero, for example. If you want to plot the wells, you just have to copy well zero. The problem is that the well is not in layer one, so here, and I think here we have to say layer is equal to 2. Let's see if this works. Yeah, this works because there are wells that are not even in layer 2, they are in layer 3. Okay, if you are here with me, please type 2. Now we are going to work with the implementation of the seawater intrusion model. EHB is equal to GWF get package of the GHB. EHB stress period data is equal to NB copy of the GHB stress period data dot array. Okay, so we define the auxiliary GHB dot auxiliary because it was not defined. And this is concentration. Okay, so GHB auxiliary is concentration. And then we transform the cells of the GHB, okay, in a list. Okay, so for example, GHB SPD is a dictionary, okay, but we wanted just for the first stress period to list. Okay, so this is a list, okay, but we need a value for the auxiliary, so I say is equal is equal to item plus 0, comma, for item in GHB list. Okay, so we need a value for the auxiliary. Okay, great. Because this is the, okay, when we are working with the this V, we have the layer, the cell ID, okay, and then we have, for example, this is the head and the conductance, and the variable for the, this is the variable of the uh, auxiliary, okay. Okay, and then we create GHB SPD. Okay, and then we create a new, okay, a new dictionary, okay, with the with this column for the auxiliary. Okay. In order to make changes, okay, because we have to make changes to the GHB, in FlowPy we have to delete the previous package, so that is why we use remove package. Okay, and then we create it again. Okay, great. So that is why is the auxiliary? Because we have to link a flow model to a transform model, and the link in between the flow model and the transform model is through the auxiliary. That is why we need the auxiliary in the flow model. Okay, if you are here with me, please type 3. If you are here with me, please type 3. Great, you are doing amazing. Okay, I strongly recommend that you follow the material, because on the material you have a better, okay, you have a better insight of what of each step. Okay, so just in case that you want to understand something better, go to the material that Gabriela has prepared. Then we need the relation in between the concentration and density. Okay, so we got the relation, and then we insert that this slope into the into the by package. There is what is the zero on the PD? Okay, great question. Uh, okay, we are going to. Okay, so mhm, no, yeah. Okay, so let's see what is a PD here. On the package data, we have I row is the specimen. Okay, so this is the first specimen. Then it comes the slope. Okay, then comes the initial value. So what does it mean? That for concentration of 0, you will have the fresh density, and then so this is the on the linear equation. Okay, this is the C0, so means that for a concentration of 0, you will have this initial value. Okay, so this how say, okay, this is the first species. Okay, this is the slope. Okay, uh, this fresh density, okay, it will be at 0. Okay, and then that's it. Okay, this is something like that because then comes the model name and the auxiliary. Yeah, the model name and the auxiliary. Okay, Kimonas, if you are here with me, please type 4. Okay, great. Then we instantiate our transport model. Mhm. and then mhm. Okay. Starting concentration is equal to MP zeros of this V and lay data, this V and CPL data, the type MP float of 32, GHB list is equal to GHB dot stress period data dot. Okay, so this is the starting concentration. This is the discretization of the groundwater transport. Okay, and from the GHB list, we are going to apply the initial concentration, okay, to the, we are going to create an array of the initial concentration, okay. So for GHB item in GHB list, STRT concentration of GHB item of 0, of 1, 35, and the initial concentration. And what is the initial concentration? Is equal to flow pi mf6 dot modflow GWT IC of GWT STRT is equal to STRT concentration. Okay, great. So we can plot the initial concentrations with this, Control C, Control V of the layer 1. Plot array, map view, plot array, CRT concentration, masked values is equal to plus -1 E2 plus 30. CMap is equal to PLT CM summer. Okay, so we are going to plot the CMap. Then we are going to get a color bar of plot array. So this is the initial concentration of the model. If you are here with me, please type 5. Okay, now we are going to work with the advection. And the dispersion. And the porosity. Okay, and we are going to the sink and source as well. That say the sink and source says that whatever comes from this auxiliary, okay, will be a source. Okay, okay, will come with concentrations. Okay, this is kind of confusing what is a constant concentration, but what this single source is the flux. Okay, so whatever water comes from there, okay, will have whatever water comes from the boundary condition will come with concentration. Mhm. And then we have the constant concentration package. Okay, you will see that the slices are different because we are not working anymore with rows and columns. We are working with cells IDs. Uh, Great question from Kimona. Say, how do we know where to apply that? That is a basic question because, uh, yeah, okay, in my opinion, the constant concentration package didn't exist in previous versions of the buy package or the transport package. Okay, it is recent. Okay, you can play around if the model works without the constant concentration. What is the question, Kimona? Say because there are no cells. Uh, the yeah, there are no, there are cells, but they are not arranged in rows and columns. So that is why we pick when we pick this, for example, the GHB, we are actually picking the cells that where the GHB is applied, or the ID. Okay, and that is why we apply there. Is that understood, Kimonas? Or you can rephrase the question. Okay. How do, okay, okay. The step of visualizing the cell and picking one cell and giving the ID, I think it can be done if you export that to a shape file because the cell ID will be exported as well. However, uh, the other question is, but it's not practical. Okay, what we say about practical is that we know that the cells that are of constant concentration are the C. Okay, so that is why we pick it from the boundary condition. Okay, but the other step can be done through by exporting to the exporting the cell array as a shape file. This is array. Okay, great. And then we can plot our boundary condition. Okay, and this is the initial concentration, the constant concentration boundary condition. Okay, then we can plot the output control. Okay, the output control, and then we define the model exchange. Mhm. This is the link. So then we write the simulation. Mhm. Okay, so in model by we have the simulation. We have written the simulation. Okay, and then we can run the simulation and hope that everything works well. Mhm. Uhu. Uhu. Okay, I will rerun again. Okay, let's see model by mfsim.num. What it says is that Tupac model cannot be opened, but Tupac model is here. Okay, maybe here I have to set the relative path to model by. Okay, let's see. Let's run it again. Let's see if this worked this time because the other time was not working. Mm, okay, again. Do you have the same do you have the same error? Kimonas. Mm. Yeah, what I see, okay, I will do something. I will go to the simulation.num, tupacmodel.num here. And on tupacmodel.num, yeah, we have the Tupac model with capital M. Yeah, and let's see if I pass to capital with lowercase m, and let's see if this works. Okay, once again. Okay, before running, I will rerun everything before running. Okay, I have here the Tupac model.num. Mm. Ah, here. In model by, I have the Tupac. Mm. I have changed that. Let me see. Okay. Mm. Mm. Ah, this is the course content. Sorry, 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 sorry. Sorry, 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 sorry. Mhm. Mm, yeah. Ah, okay, 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 okay. tupacmodel.now. Yeah, look, this is looking for tupacmodel.ghb, but this is false. Why is false? Because the noun file is looking for the Tupac model, the other Tupac model, the with capital M. And what happens if I, okay, just save it like this. Mm, 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 mm. Oof, oof, oof. The other day we could cope with that, but now I cannot. Mm, okay, okay. Yeah, okay, let's see this one. Mm, 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 mm. Okay, I will have to tell you the truth, I will have to take a look on the code, okay, to see what is going on, why it cannot open this Fortran value, okay, because what I see here is that it's looking for the right file, yeah, but somehow cannot find it, okay. Uh, really don't know what is going on here. Okay, I will have to have a look on that, and well, I think that we can stop the class here.